Today, this is section 1.2 again, day 2, our second day of doing 1.2. Our objectives are to make and interpret histograms of quantitative data and compare distributions of quantitative data using dot plots, stem plots, or histograms. We talked a little bit about that last time. We'll talk about it again today. First of all, what's a histogram? A histogram, it looks like a bar graph. The bars, though, in a histogram are always touching, because what we do is we create groups of the for the observations to go in. So we're going to count what goes in each bin, we call it, or class is another name we give to it, to the groups. Okay? And so, for example, we might have numbers from 0 to 9, 10 to 19, 20 to 29. Notice these are always the same size. The bins are the same size. Okay? And we're going to show how to make one right now with an NBA scoring averages example. This table presents the average points scored per game for the 30 NBA teams in the 2012 and 2013 regular season. So if we're looking at this, we look and we found that the lowest score was 93.2 and the highest scoring average was 106.1. Okay? So we want to make a histogram. So the first thing we have to do is decide how we're going to group the data. And we always have to start with something lower than this and go to something higher than this. So one way you might do it is, as I've done down here, I made my groups from 90, and I started at 90 and I went by fives, 90, 95, 100, 105, 110. So I made sure that I was below my lowest observation of 93.2 and above my highest observation of 106.1. Now, and then what we do is we just count from 90 to 95. You can see from 90 to 95, there's 1, 2, 3, that fit there, 4, 5, 6, 7. Over here we have a seventh one, 8, and then 9. We have 9 of them, 9 teams that scored between 90 and 95 points. And so we put 9 in there. And then we would complete the histogram by counting how many teams scored between 95 and 100, and how many teams scored between 100 and 105, and so on and so forth. And notice that we well-labeled graph. I put frequency, so it's a count, and I put points per game. We always have to have a well-labeled graph. Now, this one I would say is a little inferior to the other one I'm going to show you, because it only has 4 bars, and sometimes it's hard to tell things about shape when we only have 4 bars. When we have a few more bars, I usually tell kids to be about 6 or 8 bars is usually a good way to go. So I'm going to go back here, and I noticed that I did 90 to 95, but nobody averaged less than 93. Nobody averaged less than 93. So maybe I'll start at 93, and then instead of going by 5s, I'll go by 2s. And I'll go by 2s. So 93 to 95, and then to 97, 99, 101, 103, 105, and 107. Those would be that's where I would stop at 107. And that gives me 1, 2, 3, 4, 5, 6, 7. That'll give me 8 bars, which would be much more informative than if I only had the 4. So again, we start here, 93 to 95. Well, those same 9 teams that went from 90 to 95 are also in the 93 to 95 category, because nobody scored less than 93 points. Now, it separates the 10. We had 10. Like over here, we had 10 from 95 to 100. But those are going to be separated between the 2 categories here, maybe even over here. Well, we have 95 to 97. We had 5 teams that scored 95 to 97 points. 5 teams that scored 97 to 99. Now the 97 goes in this bin, the bin above it. 97 starts the next bin. So 97 would not go over here with 95 to 97. It goes from 97 to 99 anytime it's exact. 2 teams scored from 99 to 101. 5 teams scored from 101 to 103. Only 1 team from 103 to 105, and 3 from 105 to 107. Now that's a better histogram, it was well labeled because of the bins. Gives us, you can see there's definitely, kind of a skew here. It's definitely not symmetric. kind of a skew here, skewed to the right, because there are a few teams up here and many teams over here. Almost 20 of the teams are below 99, and only 4 of the 30 teams are above 103. So definitely would say there's a skew there. Okay. All right. Last thing we need to look at: comparing distributions. When we are comparing distributions, we're going to compare the shape, the center, the spread, and any outliers. And we want to give as much information as we can. Okay. So let's look at, and we'll do this one together here, energy cost, top versus bottom freezers. How do the annual energy costs in dollars compare for refrigerators with top freezers and refrigerators with bottom freezers? The data below are from the May 2010 issue of Consumer Reports. Okay. Well, let's look at the bottom freezers. The bottom freezers, the energy cost, very spread out. Very spread out. There's a peak here around 70. And so what we want to talk about is the shape, center, and spread of both of these. And if there are any outliers. And then anything interesting that we might note about the distributions. Okay, so let's do that. Well, when I'm noticing that if I'm choosing, top freezers certainly look like they're going to be a lot more energy efficient. Our cost is going to be less. Okay, so we might say something like this: the bottom freezer group has a mean or a middle of about 70. A fairly strong skew to the right, and a spread that goes from about 50 to about 150 or 160, somewhere in that range. 2 of these refrigerators appear to have unusually high energy cost about 140, 150 or so. Thus are outliers. Okay. Now we want to compare the other group. Certainly the top freezers is much less spread out. Okay. Its center is lower. Okay. The top freezer group is fairly symmetric. Remember, we're not looking for perfection, but it's fairly symmetric. You might say there are peaks with a center about 56, much lower than the bottom freezers. Okay. It also has a much smaller spread. From about 50 to about 68. Okay. And one last thing that I would note here about this distribution is we try to note things that are interesting. And the interesting thing about this is that all of the top freezers have an energy cost that are less than the average for the bottom freezers. And I would note that all of the top freezers have a lower energy cost than the average cost of a bottom freezer. Makes it pretty clear that you don't want to buy a bottom freezer, you want to buy a top freezer.